On July 2nd, 1962, the first Walmart store was opened in Rogers, Arkansas. It was built with one mission: to provide the lowest prices anytime, anywhere, helping people save money and live better. In the 1980s, the first Walmart Supercenter was opened. It combined a supermarket with general merchandise, redefining convenience and one-stop shopping. By the 1990s, Walmart rolled out supercenters nationwide across the U.S. When we entered the 21st century, Walmart continued to grow even more. Today, Walmart has a massive supply chain network with over 4,600 stores, 117 distribution centers, 26 fulfillment centers, 3 sortation centers, and 96 transportation offices. This network serves as Walmart's backbone for providing customers with a seamless and convenient shopping experience.
My name is Minggang Fu. I'm a Senior Director of Data Science. I lead the Supply Chain Science arm as part of the Applied AI group at Walmart Global Tech. And I'm proud and thankful to introduce Walmart's application for the Franz Edelman Award. From grocery entertainment to sporting goods and crafts, Walmart provides a deep assortment of commodities that our customers appreciate, no matter they are shopping online at walmart.com, through our mobile app, or shopping in a store. Today, we are going to present how during unprecedented times of COVID, a period of high ambiguity and volatility, Walmart evolved and transformed our grocery supply chain while keeping customer promise of everyday low price. This effort to evolve our long-term supply chain strategy while at the same time keep improving our current processes paved the way of end-to-end holistic thinking. You will hear from my colleagues who comes from all parts of Walmart: technology, science, product, operations, collaborative to build a unified solution to support decision-making from strategic network planning to executional real-time operations. Specifically, number 1, network design. What would the end-state network look like in 10 years? Number 2, what is the step-by-step approach to reach the end state from where we are right now? Number 3, giving a snapshot of the network design. How to efficiently operate the inventory flows from distribution centers to the stores. And last, simulation. How do we leverage the algorithms and the models we built for executional operations to benefit our mid and long-term strategies? We are going to talk about the journey of implementing the solutions, the macro and micro levels challenges we faced, and how we leverage operations research and advanced analytics to not only achieve these two objectives, but also provide a positive impact to our environment and business, improve our associates' experience, and serve our customers when and where they need us most.
Walmart has historically been an operation research leader. We have been using that across the board in optimizing a lot of our transportation, our replenishment, and fulfillment systems. Over the last few years, our consumer behaviors have changed. People have moved away from brick and mortar to digital e-commerce, and during pandemic, it became even more so. But after the pandemic, it has evolved back into the brick and mortar, and there has been a balance between both e-commerce and brick and mortar. So we want to meet the customers where they want it, when they want it, and how they want it. So Omni has become the key important piece here, because we have to make sure that we are meeting the customers both digitally and also in the stores. And more our store shoppers also want a digital presence so that they can actually order online and pick it up in stores. So when you have to do all this, we need to make sure that everything from stores to fulfillment centers to distribution centers are all operating on the same stack and driven from the same data, and uses operation research to really make it come to life for the customer. For the first time, the team has leveraged operation research to fully adopt the optimization models, which helps us make investment decisions at the network level for future network, and also load planner at the execution level.
So historically, we had very siloed network operations and strategy. So We had a distribution center strategy supporting the ambient network. We had a perishable distribution center strategy supporting our fresh and perishable products. We had an e-commerce strategy supporting our online customer, and then we had a store strategy supporting our in-store and pickup customers. This resulted in suboptimal utilization of our assets. This also resulted in lack of flexibility in being able to use assets for multifunctional use cases, especially considering the changing customer behavior pattern. Over the last 2 years, we have embarked on a journey of transforming our supply chain to support an omni-channel customer. That is a customer who can shop in-store, online, or pickup, or even in the delivering to a customer's refrigerator. Our assumptions on supply chain have also changed drastically over the last 3 to 4 years. Our assumptions on what automation can provide to our business, our assumptions on flexibility, the need for having flexible assets, that's different. We had to build multifunctional assets that are able to support these multiple shopping occasions as well as potentially different product categories. The other important change in our strategy is the introduction of automation. So we are launching automation in a very big way into all our assets that help improve our productivity, our overall network productivity, as well as reshape the quality of work that an associate does inside our DCs and FCs. In addition to that, we are also infusing a high level of operations research and data science into our strategic thinking so that any models that we build are robust enough to account for multiple scenarios that can occur given the changing macroeconomic environment conditions.
Walmart already operates a very efficient supply chain. We are the largest grocer in the US. We serve 150 million customers, and we use operations research in almost every aspect of our supply chain, from pick path optimization to labor scheduling to job scheduling. Operation research is part of everything we do at Walmart. What made this solution unique was the fact that we used operations research not only on the strategy side, but also on the execution side, but we brought them together. And to understand that, we need to understand what strategy and operations actually mean in supply chain. When you think of strategy in supply chain, these are usually long-term, irreversible decisions that a company has to make. For example, where should we open a warehouse? How much capacity should be in the warehouse? What part of US should it be located? The execution or operations in supply chain are decisions that you make on daily basis to help run your supply chain. For example, how do you want to route the trucks? How much labor do you need in a warehouse, etc., etc. Usually, the decisions that you make on the strategy side find its way as a constraint on the execution side. And as an operations, as a data scientist who practicing operations research, it's those parameters that we optimize on. A good example of that is we made a strategic decisions of how much warehouse space we need, and that becomes a constraint on the operations side, that you have a finite space in your fulfillment center. And Walmart decided to invest in its grocery supply chain. As a data science team, we thought, look, you know what, we'll use operations such as on the strategy side. We'll also use it on the execution side with the load planner, but we'll have to somehow bring it together and make it more agile and enable Walmart to make holistic end-to-end decision making, which is what this solution is about. To summarize, there are 3 key things that I want to call out that the team has developed, and I'm very proud about that. The network strategy work of how Walmart should evolve its network strategy. This is the other strategic decisions that we make. Load planner, which I think pushes the limit of efficiency in our supply chain. And lastly, how the team brought these two together and built a simulation platform for Walmart. And you'll hear some examples. And the end result of all this was that we made decision making at Walmart holistic and agile.
At Walmart, we follow a 4-step hierarchical decision process for designing, planning, and executing our supply chain. It starts with outlining the future state network. Next, we create a transformational roadmap with a detailed year-by-year plan to get from the current to the future state. Given that it would take several years to realize such a long-term investment, these types of decisions usually look a couple of years ahead and are followed by the finance approval process. Next, the output of these strategic decisions is consumed by resource planning across the supply chain. At this step, decisions are evaluated by the simulation platform and determined on a yearly and quarterly basis. These decisions include things like store to DC alignment and capacity planning at each node. Then we make executional decisions, such as how to efficiently pick, load, and route products prior to moving them. Finally, as products are physically moved through the supply chain, dynamic decisions are provided to help our associates make changes in real time. In this multi-tier decision process, we first built a set of scalable optimization models to empower strategic network design and transformation decisions. Then, at the executional level, we built Load Planner, which consists of many state-of-the-art optimization engines. Load Planner is able to make efficient executional plans and dynamic decisions in real time. Most importantly, Load Planner provides a simulation capability, which enables us to evaluate the impact of various scenarios while making strategic and tactical decisions. Building all of these optimization capabilities was incredibly difficult, and we faced numerous business and technology challenges along the way. Now, we will deep dive into each piece, starting with strategic network design.
The growth in grocery business in the recent years and our future projections demanded us to redesign the entire perishable network. When the business team reached out to us to see if our data science team could help with the perishable business strategy transformation, we took on the challenge. We saw it as an exciting opportunity to apply advances in operations research to a non-traditional area like strategy. Our business team had two goals. First, design the future network, which defines the optimal number of perishable distribution centers, known as PDCs, and their locations across the United States. Second, create a transformation roadmap, which includes decisions like when to build the new DCs, close or retrofit existing DCs, and enable automation capabilities. Both of these goals had a unique set of challenges. For example, consider the transformation roadmap. While an existing building is being automated, some part of the building becomes unavailable for current operations, resulting in reduced throughput. This meant that this transformation needed to be executed while keeping the existing supply chain running reliably so that the customer experience isn't compromised. It's like changing the engine of an airplane while cruising at 30,000 feet without the passengers feeling any turbulence at all. And then, when we looked at the network design, it had the challenge of scale. Walmart has a network of over 40 PDCs. These PDCs ship grocery to over 4,700 Walmart stores and 600 Sam's Club. We made an assessment that if we tried to solve the entire problem in one go, we would have a massive model with over 100 million decision variables that would make it intractable. The ideal model size we determined was around 1 million variables, enabling us to evaluate several what-if scenarios. Then, we set out to build two models, the end-state network design model and the transformation model. We will refer to them as the first and second model, respectively. The objective of the first model was to minimize the total cost, which included fixed, variable, and transportation costs, which are all constrained by various channel capacities and locations. The model output provided the optimal long-term end-state network in terms of PDC locations, PDC capacities, and PDC to store alignments. The plain vanilla end-state model was huge. It had close to 10 million variables when we started out. To make it manageable and quickly solvable, we considered various business rules and tried to reduce the search space based on various techniques that used machine learning clustering and neighborhood generation algorithms. This reduced the problem size to a fraction of a million variables and got us to where we wanted it to be. We call the second model the transformation model. While the first model gave us the end-state network design, we still had to find out how to reach that end state. So the second model takes the output of the first model with the goal of figuring out exactly what time points to start or stop the construction of different assets and provide the exact timeline over the next 10 years. Because of the granular nature of this second model, it was massive, and it had close to 50 million variables to start with. This is 5 times as big as the initial version of the first model. To reduce the size, we resorted to techniques that iteratively reduce the variables over time which got us close to our target of 1 million variables that made it manageable for us to solve the problem. With these models, we were able to run hundreds of scenarios. Why did we need to evaluate hundreds of scenarios? Because the future is unpredictable. How things are going to be 10 years down the line is very uncertain. That's why we need to run scenarios ranging from pessimistic all the way to optimistic input configurations. This allows leaders to quickly evaluate many scenarios based on macroeconomics and be able to make sound decisions based on the outputs. Providing the results from these hundreds of scenarios accelerates the decision-making process. What do I mean by the decision-making process? This refers to the financing of assets such as the PDCs. The decisions could be about building new PDCs or modifying the nature of the existing PDCs, which we call retrofitting. So all these decisions, when and how much money we are going to spend, are the decisions the leaders make. Multiple scenario evaluations accelerate the process of decision-making and allow them to make the right decisions with confidence. The model output in its raw format is a time-phased roadmap, but it's not easy for executives to visualize. So we built a simple dashboard to help leaders easily visualize the transformation. The dashboard consists of multiple portions. The first portion is the ability to run the model itself. But even if you had a result from a previous run, you could just upload that and look at the key performance indicators, also known as KPIs, to get a good idea of how that scenario works. Then, drilling down further, we look at the US map and the nodes. And you have an animation that from time to time over the next 10 years shows how things are coming in, going out, and how they are getting modified. All that information is captured in that animation video. The work we have done for this project is transportable to other areas. Although this body of work was specifically developed with our perishable network in mind, we are also working on extending it to our ambient network. And the same process can be followed in other areas of our business. So this can be seen as a great first step we have embarked on, and we are excited to work on various other projects to unlock huge potential for Walmart's supply chain.
After we have designed and planned our network, we need to start to thinking about how we are actually moving the things to our customers' hands on a daily basis. Here is executional planning kicks in. Right? So to better understand our business process, then let's first take a look at our detailed decision flow in today's grocery outbound execution.
When a grocery distribution center receives orders, the warehouse management system kicks into action and plans picking trips, creating a set of pallets that need to be built. Once we have those pallets, we can get started on our routing plans. It's all about making sure we get the products to the store on time, while also minimizing costs and maximizing efficiency. To ensure the feasibility of a route, each route generated at this stage is guaranteed with a feasible way to arrange the pallets, compartments, and temperature settings in the trucks, so they comply with the required rules for handling perishable products. Next, our Transportation Command Center associates review and revise the routes to make sure everything is feasible. They make any necessary changes to ensure everything will work as planned. For each route, we generate the best load plans to ensure everything is loaded in the most operationally friendly way possible. These loading plans are then reviewed by Transportation Command Center associates who make any necessary revisions. Then, pick and load activities start at each distribution center using the plans we've made. During picking and loading, sometimes unforeseen situations pop up, such as a pallet isn't ready to be built, or the loader accidentally loads something in the wrong spot. When this happens, we help the loaders adjust the load plan on the fly, while making sure that we're still meeting all of the necessary loading compliance requirements. Lastly, our drivers drive trucks to stores along the planned routes, and at each stop, store associates unload pallets using the plans we made.
At the core of Load Planner, there are 8 optimization engines that are powered by our state-of-the-art algorithms, and they serve as a backbone to support each step of our decision-making processes in execution. A routing engine is the major engine within the Load Planner. It generates the most efficient multi-stop route to deliver the pallets to the stores and within stores' receiving time window. It usually runs for each commodity at each DC each day, and it takes up to 15 minutes to complete. The biggest complexity to generate a very efficient routing plan lies in dealing with the perishable products, such as say, strawberries, ice creams. Those products require the strict cold chain compliance throughout its entire storage, handling, and transportation process. So in the United States, we often use a 53-foot long temperature-controlled trailer to transport those perishable products. This type of trailer has 2 movable bulkheads, which can divide the inner space into up to 3 compartments, and each compartment has its own temperature settings. So now when it comes to use this type of trailer for multi-stop routing, the traditional way of just simply adding up the cubes and the pounds of the product to check against the maximum capacity of a car in the vehicle routing problem is not working anymore. So to summarize, we must solve for a routing problem with the consideration of the loading problem. And we must also deal with over 50 rules and regulations and constraints that from a real ask covering the things like transportation safety, loading safety, operational efficiency, cold chain compliance, and delivery time windows. We developed a meta-heuristic framework that integrates a wide range of the algorithms, including heuristics, neighborhood search, mixed integer programming models, and clustering models. And this routing engine sits at the center, which is interacting with another 3 fundamental engines. Let's start with the hours of service engine. It runs within a millisecond. Just try to answer one critical question, which is, given a stop sequence, can we come up with a timestamp of a route complying with all of the delivery time windows and also comply with the drivers of hours of service regulation? Similarly, our fiscal loading module is trying to answer another critical question, which is, can a group of pallets fit into a trailer? There are many possibilities to place a pallet into a temperature-controlled trailer with different compartment settings. And it is almost impossible for us to iterate through all of these combinations within a millisecond. So what we did was that we leveraged a predefined loading patterns to narrow down the search space. As you can imagine, the speed and effectiveness of the engine is the key. That's why we have invented a couple of innovative algorithms that specifically focusing on improving the computational performance. The third engine that empowers our routing is the stacking, which is simply decide whether we're going to put a stack on top of each other. We decoupled stacking from loading logic. And it helps us to reduce the dimensionality of a 3D bin packing problem into 2D by removing the height dimension. So now in the loading problem, we only need to deal with the width and the length of the pallets, making the problem much more manageable. Another goal for us to build a load planner is to improve experiences of our users and operators. We believe there are 2 ways to achieve such a goal. First, by making our decision process more transparent and understandable instead of a black box. Second, by providing the plans which are more operational friendly. So that's why we have developed 4 core engines to serve this purpose. The first, dynamic routing engine, would enable our transportation planners to experiment with their own ideas. They can drag and drop pallets from one truck to another truck and receive intermediate feedback of whether it works or not. The sub-second response time of a dynamic loading engine truly enables the real interaction with our loaders at the distribution center. Now, the loaders at the distribution center, they can ask load planner on their handheld devices anytime to upload or to re-optimize the loading sequences for them. Optimal loading engine actually takes into account of a lot of different objectives other than the cost objective. It takes the operational friendly objective, such as how about let's minimize the number of reloads? How about let's balancing out the weight at the curbside and the roadside of a truck? One of the innovations that we have to call out is the fluid loading module. In this module, we leveraged the algorithms to define a loading blocks, and very interestingly, within each of the loading block, You can pick any of the pallets and load to the trailer at any time without considering the sequences. This would significantly reduce the complexity in our loading and improve our loading productivity. Over the past couple of years, we have patented dozens of the innovative algorithms. And what is even better is that with the extensive experimentation and historical data, now we develop the intelligence to be able to select the algorithms and the best parameter settings based on different problem characteristics. I believe it was the diverse set of the algorithms and this intelligent selection made load planner highly adaptable and highly extensible.
So the routing and loading capabilities offered by load planner could be leveraged by other networks within Walmart, such as the general merchandising outbound network, the reverse logistics network. Moreover, the same set of capabilities could be leveraged by non-Walmart users who runs similar DC-to-store distribution operations. And the hours of service module we built into the vehicle routing solver is generally applicable to any long-distance commercial truck routing problem. Now that we have built fast and powerful algorithms and models that support the decision of both strategic and executional, but it doesn't stop there. Integrating these two in form of what-if analysis unlocks a greater potential. So network design and planning usually involves analyzing various scenarios defined by the parameters such as DC to store alignment, trailer configurations, and store delivery frequencies. For example, what if we change a set of stores sourcing DC from one to another? Or what if we use the temperature-controlled trailers to only carry single temperature commodities? Or what if we reduce the delivery frequency to a store from 7 days a week to 5 days a week? To answer all those questions, we built a simulation platform with Load Planner's optimizer at its core. It's a pretty user-friendly product which allows users to quickly configure what-if scenarios and make a run and review the results in a few minutes. Let's take store realignment as example again. So users enter the systems and then configure a simulation run scenario, realigning a set of stores to a set of new DCs, and click the button run. In a few minutes, so the cost impacts on transportation, DCs and the stores will be calculated and displayed. So when we build this simulation platform, we always keep the system thinking philosophy in our mind. We focused on building the connections of different modules, trying to explore what's the interactions between them and provide the end user with an end-to-end holistic view so that they can make a better decision to benefit the entire Walmart supply chain. This simulation product plays a critical role that it connects the execution and the strategic data science modules together to create an end-to-end solution. The super fast computing performance of this simulation product allows us to run more scenarios within a shorter amount of time, which eventually yields a better network design. And the better network design will benefit Load Planner by raising its ceiling to further improve the operational efficiencies. So with the strategic and executional decision combined into a unified solution, we were able to unlock the unprecedented synergies, which is greater than the sum of all parts.
In 2020, we started really looking at how do we merge online e-commerce with in-store fulfillment in the grocery space. And then in 2021, we opened our first next generation fully automated grocery distribution center. And that really got a lot of people excited about the future of the network and the future of next generation automation capabilities inside of the distribution center and inside of the networks. So at that point, we started developing mixed integer modeling and programs to help us really establish what would be an optimal future state network for Walmart. And then in 2022, We use those models to then present to senior leadership what our recommendations were. And so we were able to get the strategy holistically approved as well as capital funding for the next set of assets in that transformation roadmap last year. When you come out on the other side and the building is retrofitted with our next generation automation systems, and then it's a better work environment for our associates in the DC and a better service experience for our stores and our customers.
We started building Load Planner as we were developing our network strategy, which is an evergreen process of evaluating where we need to build our physical assets. As part of that strategy, we knew that we needed to invest in product and technology to optimize our loads better, digitize our workforce, and improve our service to stores, communities, and customers. It took about 4 years, extensive collaboration between product, technology, operations, both in delivery and supply chain, store operations, and through that collaboration we were able to successfully test. We piloted at one distribution center that supported about 100 stores, and as that process was going really successfully, we eventually had people asking us to be onboarded onto Load Planner, and we had a very successful rollout that was completed in about 4 years start to finish. The product and tech teams built this in a way that is highly configurable, and we're able to make changes on a dime to get freight to our communities and customers a whole lot faster than we have been in the past. The on-site support was nothing short of incredible. The way that the data science team, product team, engineering, tech, and the business were able to quickly assess the changes that needed to be made and deploy those almost real time is something that we haven't experienced a lot in the past, and it is definitely setting the way for how we need to operate in the future. Walmart is a very large company, and historically it's very easy for us to work in silos because it's really challenging to get the number of people across the organization together to think through the solutions that we need from an end-to-end perspective. Load Planner is a tool that will inherently help us be better from when we pick up the freight in China all the way to the customer's refrigerator. Optimizing those decision engines in a way to deliver a quality and expected level of service for our customers and managing our costs is a massive unlock. The other value of Load Planner is that they're building it in a way to integrate with our other products and technology. So stores can be more aware of when their freight is on the way and are ready to unload their product. Additionally, because of the way that Load Planner, again, was built to be very configurable, we have the ability to go in and make sure that we're appropriately representing the unload times of individual stores. Historically, we had to make large decisions that impacted all 4,600 stores instead of taking a very granular approach to really reflect what the actuality was going to be, resulting in improved levels of service to our stores. So the scope of Load Planner is very extensive. We started with our grocery distribution network. We have about 48 grocery distribution centers that deliver to 4,600 stores, Walmart stores in the United States, and all of our Sam's Clubs that are within the United States. However, we are already working on plans to expand Load Planner into our regional distribution center, our fulfillment center network, to make better results for the customer. All of these products coming together is the competitive advantage for Walmart. Understanding the automation in different parts of the organization and how these decision engines will work together to optimize how we're getting freight to our customers and to our communities is a big deal. And it's what's going to help us win long term, and it's what's going to help the communities and the customer. Walmart's mission is to save people money so they can live better. We are a people-led, tech-empowered company, and Load Planner is the epitome of what that looks like. The organization got together to collaborate, people-led, but now it is tech-empowered, reducing the amount of time that it is taking for them to do their job so they can help customers live better.
It is incredible how much time it has saved all of us. Because if you look at it, there are 3 different commodities that a load logistics manager routes throughout the day for 48 different grocery DCs. And if you're saving an hour and a half a day for 3 commodities for 48 DCs, that's a lot of time. And that's going to equate to savings for our customers at the stores.
So in the past or whatever, it was all, most of it was manual. You had to plan the pallet positions on the trailer, and you had to have the right, temperatures in the right spots, and the right stores in the right spots, and certain weights in the right spots. With the load planner, taking that out of the equation, when the new hire comes in off the street that doesn't have any experience or whatever, you can have them trained up in most of the time less than a week.
The importance of LP is the organizing of the routes, the different commodities, the different sizes, the different stores, to be as efficient as possible on these grocery routes to get the food out to America.
Some of our biggest changes that we've seen over the last year since we've went to the newer system is just weight is one of them. We've used to have a lot of reloads with weight issues on whether it be roadside or curbside. And this new system's allowed that to eliminate.
In fiscal year 23, Load Planner unlocked over $90 million worth of operating savings, and that came through reducing the number of routes, which is the number of trailers, the number of trucks that we have on the road, as well as the miles driven to support the 4,600 stores and all of our Sam's Clubs for delivering grocery freight. Over the past few years, there have been numerous impacts to supply chains across the country and across the world. A lot of those impacts are uncontrollable through natural disasters, be it wildfires, snowstorms, flooding, hurricanes, tornadoes. We know that 90% of Walmart customers live within 10 miles of a store. So when a disaster strikes, as predictable or unpredictable, the ability to get the necessary goods, if it's bottled water, if it's paper towels and Clorox wipes to clean up after events, or even if it's supporting charities, the Red Cross with food donations, etc., the ability to react and respond makes a difference in thousands of communities across the country.
Throughout this presentation, we have demonstrated the collective efforts of a large number of Walmart associates during the past 4 years. So we have described how we brought up a very diverse group of people from technology, science, product, and operations to come up with a unified solution that supports decision-making across all tiers of supply chain management. We are proud of the breakthroughs that we achieved throughout the development and implementation in this journey. Specifically at a strategic level, we have developed highly scalable and flexible models to solve the entire network of Walmart, which we could not have achieved before. We bridge the gaps between theoretical study and then real-world industrial applications by solving routing and loading problems simultaneously with rich, complex operational constraints. We develop an exact method which solves variable size multi-compartment trailer loading problem at millisecond level. Last and most importantly, with the new paradigm of end-to-end thinking, our unified solutions has achieved sizable impacts from multiple aspects. Our perishable network strategy, we have already seen a strong adoption by the users. Confidence has been built, which will accelerate our future transformation. And on the execution side, it saved millions of dollars, avoid millions of pounds CO2 emissions, which is in line with Walmart's long-term commitment to create a better environment for us.
Well, hello, and thanks so much for considering Walmart for the Edelman Prize. We're honored to be a finalist. And as someone who's worked for Walmart for almost 30 years, I've truly seen the impact of operations research. And Load Planner is a great example. And nothing like that existed when I started working in our facilities, but we're using it now, and it's amazing to see. An important step change in recent years has been using operations research to evolve our supply chain strategy. And there was a time it was only used for execution, but to have the synergy between strategy and execution has been a huge win. A good example of this was when Hurricane Ian struck Florida last September. The hurricane cut off the flow of goods to many of our stores. We had to close 252 facilities, and it was devastating. But I was so proud to see our team use research to reroute deliveries from other hubs, and then they could predict how demand for goods would change. And that helped us quickly reopen our facilities and get back to serving customers. I'm so proud of the work our teams did to get us to this point, and I'm so excited about the future it's unlocked. Thanks again for considering us.